Good evening to all. बस पेन चाहिए. Yeah. Is that audio and video fine? Again lagging. Looks like. Guys, just let me know. Is everything fine? कुछ lagging है audio video में? They're lagging again, right? Yeah. Good evening, Sakshi. Yeah. Good evening. I'm trying my best, to make it smooth, but let's see what will happen. आज क्या हुआ यार? कल का इफेक्ट है क्या इसी? Again same error, right? Video is fine, but sound is not. Actually, video is also not fine. We can see some error, guys. Okay, so let's see, is audio and video clear? Looks like clear or not. Now good. How is that possible? No voice. Sound is not coming. You guys tell. Let me know. Audible. Calchal. Now sound is fine. What about the class? All clear? Really clear? यार let me know यार. मुझे क्लियर बोल रहा है, एक बार देख लेना. रिफ्रेश एक बार रीलोड उसका, इसका रिफ्रेश कर लेना एक बार, इसको रिफ्रेश कर लेना. We can start. Oh. Okay, now clear, completely fine. So how many of you are waiting from the last half an hour, right? So many of you are waiting here. Biswajit, we can start, but let's confirm from everyone. Only sound is little but manageable. Is it still lagging? इलेक्ट्रिकल नॉलेज आज कुछ शुरू करने वाले नहीं है हम. स्टिल लैगिंग, again lagging. So that's what the problem, right? If I start and lagging, we cannot stop. There is an issue. So what can we do? Can we postpone the class? प्रॉब्लम इसी को ठीक करना है यार, इसको कैसे ठीक करेंगे? इसको कम कर लो, इसको कम कर लो. But refresh, reload. Error. Poor voice, poor sim status is not receiving enough video to maintain smooth. Oh my god. Okay, I'm checking, guys. Shivam. Excellent. Okay, guys, I think it is done now. Let's see. Just we'll wait for 2 minutes. If everything is fine, then we'll start the class now. बताना यार audio video कैसे है अभी? Everything is fine? Fixed, yes. Looks like. Clear है ना? सब ठीक है. Great. चलो finally. Fine. ऑडियो एंड वीडियो फाइन है क्या? ऑडियो थोड़ा स्लो चल रहा है, कुछ सेटिंग्स है आपको से बढ़ाना है. इज ऑडियो क्लियर गाइस? Okay, let's begin the session, guys. The session is a compiler design, right? The compiler design or PYQ discussion. Yes, sound सब कुछ ठीक है. Everything is fine from my side. Please do from your side if anything. Please refresh the video and good. For everyone, audio and video fine, right? So myself, Maleshim Devasane, right? I'm taking the classes for TF Competition and Compiler Design at PW. Okay, so today agenda is pilot topic and lecture analysis. Of course, there are some questions which will be mixed. Don't worry about it. But we'll mostly go with the sequence. But somewhere you will see the questions mixed. That's fine. So we will be covering the 4 topics here, right? And including there's one topic which is intermediate code, SDT, and the intermediate code. Fine. Raja, is audio very low? Is it really very low? Come on, guys. 2 people are saying it is very low. All clear? Great. So let me. It's fine, right? Okay, I can see that. I'm very sorry, guys, if you are disturbing the class. Okay, let's continue the session for today. So are you ready now? I can hear my voice, which is pretty much clear. Are we ready? And no need to manage with the headphone, yeah. It's good. There's no issue with the audio and video. Please do it from your side if an issue. Let's begin the session. But before that, let me know how are you ready? It's don't know exactly what happened with the streaming, but we did some changes. Then luckily we got set. चलिए शुरू करते. Okay, the first question is, The first question is, of course, you don't need to take much time, right? But we obviously we go with different approaches. Just give me a second before starting. See, in compiler keywords of the language are recognized during parsing of the program, code generation, lexical analysis of the program. We know it's a lexical analysis, right? Now tell me what happens during the parsing of the program. क्या होता है parsing of the program, right? Here what happens? The syntax syntax cross checking होता है, right? Parsing में during the parsing. Code generation, what happens during the code generation? Producing the assembly code, right? So in the code generation, allotting the registers, allocating registers, and so many things will happen during code generation, like allocating registers, producing assembly code. Many things happens here. Lexical analysis, during this the tokens will be recognized and produced, correct? During data flow analysis, if you look at there are some kind of data flow analysis which is like live variable analysis, something like reaching definitions. Some kind of data flow analysis happens to do many things, like you want to allocate the registers, then this might help you, or you want to do the code optimization, etc. Like available expressions. Many things happens during data flow analysis. Everybody clear? Okay, we are not just answering the question, we are understanding what is each option also doing for the question, right? Yeah, dead code elimination does, but for that you need to identify live variables and many things else. Correct. Shift, you're right. Yeah. How many of you are interested again for whole night here? But I can see only some are interested, remaining all are leaving, right? Let me know. Good, good. What time you want to continue the class for today? Means till tomorrow morning. Whole night? Not for whole night. Who are night walkers here? Only for night walkers I will take the class today. Yesterday were not there, but today will be there. Okay. चलो देखते कितने लोग हैं, उसके accordingly हम चलाते class. So first question, right? The question 1 is clear. Let's go to the question 2. A very famous question so far in the exam from the lexical analysis. So you read the data. What is the meaning of, okay, read the data. There are 3 tokens are provided along with their patterns, their expressions. Now you need to understand what is this X followed by the question mark symbol, which is nothing but either 0 or 1 occurrences of X. So when somebody says X means epsilon or X, right? You got the point, right? That is the meaning of the X followed by the question mark symbol. And note also that the analyzer outputs a token that matches the longest possible prefix. We already know, right? If you want to produce a token, we always follow the maximal Munch rule, that is called as longest prefix match. All right. If the string BBAACABC, so if you want to generate this string, definitely you need to use these 3 tokens, but every time you produce, you need the longest prefix match, longest match you need to do. So let's try to understand what is it. But before that, what is the meaning of ये क्या है expression, right? इसको कैसे लिखना है? A plus epsilon, right? Followed by B plus R means you can use the bar or you can use the plus. B plus C whole star A. And the B question mark you can write as क्या है? B plus epsilon और A plus C whole star B. और क्या? और C plus epsilon followed by B plus A whole star C. तो आपको पता है यार कैसे लिखना है एक्सप्रेशन, बट ये डेफिनेशन है बहुत इंपॉर्टेंट. सो इसको कैसे लिखना है वो भी बताया है क्वेश्चन के अंदर, बट इसको फॉलो करना है आप, राइट? एवरीवन, तो आप इसको क्या किसको जनरेट करना है? बी बी डबल ए सी ए बी सी को, राइट? यू नीड टू जनरेट दिस वन यूजिंग लॉन्गेस्ट प्रीफिक्स. तो लिख लेते हैं यहां पर बी बी ए सी ए बी सी. सो हम पहले यहां से स्टार्ट करेंगे. तो यहां से कुछ भी हो सकता है, राइट? T1 T2 T3. तो लॉन्गेस्ट जो पॉसिबल लॉन्गेस्ट जो हम जनरेट करेंगे उसी को हम कंसिडर करेंगे, राइट? T1 से कोशिश करेंगे, T2 T3, बट एवरीथिंग. सो T1 जब B जनरेट कर सकते क्या? यस, T1 यहां B जनरेट कर सकता, राइट? और एक एक भी कर सकते हैं आप, कितने तक कर सकते हैं T1 वो भी चेक कर सकते हैं आप. T1 B B, सो एप्सिलॉन लेना और B लेना और नेक्स्ट B भी ले सकता और A. तो B B A, so T1 can do this much, right? Up to here B B A, right? What T2 can do? What T2 can do? Let's try again. B यहां पर है, दूसरा B यहां पर है, तो सिर्फ T2 इतना कर सकता है, राइट? B B. बट ये दोनों में लॉन्गेस्ट कौन है? T1 है. सो T2 को आप हटा सकते हैं अभी, T2 को हटा सकते हैं अभी. T3 T3 कोशिश करेंगे हम. पहले B B, सो B यहां पर है, दूसरा B यहां पर है, एप्सिलॉन पहले लेना, बाद में B B और A ये यहां पर है और दूसरा है यहां पर है, C यहां पर है. मतलब आप यहां तक ले सकते हो, C तक. B B A A C. So who is the longest prefix? T3 will generate the longest prefix, right? तो यहां तक आपको कंसिडर करना पड़ेगा, यहां तक. ये है T3. आई होप एवरीबॉडी इज क्लियर, राइट? सबको समझ में आया होगा T3 क्यों आया यहां पर. बट अगेन द प्रोसीजर स्टार्ट्स अगेन फ्रॉम हियर, अगेन प्रोसीजर स्टार्ट्स. तो यहां T1 से कोशिश कर लेना, T2 से कोशिश कर लेना और T3 से कोशिश कर लेना. T1 से ABC पॉसिबल है क्या? A B C, बट ये भी चाहिए. ABC यहां से पॉसिबल नहीं है, ABC ये पॉसिबल है, बट हमको सिर्फ ABC चाहिए. तो यहां पर ABC इससे जनरेट नहीं कर सकता, बट कितना जनरेट कर सकता? सिर्फ A एप्सिलॉन एप्सिलॉन A. तो इतना तक जनरेट कर सकते हैं हम बस. ABC के बाद ये कंपलसरी आना चाहिए, राइट? ये पूरा ABC जनरेट नहीं कर सकता हम. नाउ T2, व्हाट T2 कैन डू इट? एवरीवन, yeah, you got the answer, right? But I'm trying to explain how much you can generate here. ये यहां पर है, B यहां पर है, right? So this much you can generate for T2. But अब T3 can it generate ABC? A B C. You can take epsilon A B C. Yes, this can do everything from till here, right? It can generate A B C. So अब बताना, ये पूरा T3 जनरेट कर सकता. So T3 followed by T3. So what is the right answer? D. Everyone, जो पहली बार एक्सप्लेनेशन को देख रहा है ना, if you are looking at the first time this question, so understand how to generate the sequence of tokens for the given input. No, T3 T1 is impossible here. No, T3 T1 is impossible. Remember that. No, don't say that T3 T1 is wrong. No, T3 T1 impossible here, guys. Don't do that ever. If I give, यहां पर ऐसे दिया B B डबल A C A B C A, अब क्या होता? ये T3 से जनरेट होगा, ये पूरा T1 से जनरेट होगा. बट जब A जरूरत है ना, यहां पर A नहीं है. So remember that अगर आप T3 T1 को लेना है तो T1 should generate all thing like A including A. तो यहां पर होता T3 T1, यहां पर T3 T3 नहीं होता, यहां पर T3 T3 नहीं होता. So T1 will generate ABCA. बट ये नहीं था, इसलिए T1 को हम नहीं ले रहा है. सिर्फ A तक जनरेट कर सकता है, AB भी नहीं कर सकता, ABC भी नहीं कर सकता. बट अगर यहाँ पर A है, पूरा जनरेट कर सकता है. समझ लेना. या T1 is ending with A. यहाँ पर C है इसलिए दिक्कत हुआ. Okay, don't do silly mistakes unless you will get the wrong answers. Okay, so T3 T1 नहीं होता यहाँ पर. Fine, this is the question 2. Let's go for question 3. Let's do it, guys. Consider the following statements. You have the 3 statements. 1, symbol table is accessed only. So ये words are very important. These words are right. तो आपको consider करना पड़ेगा. Symbol table is accessed only during lexical analysis and syntax analysis. Is that correct? What is the actual statement? Symbol table is accessed during all the phases of the compiler. That is the reason this statement, you need to choose the true, but this statement is the false. Why false? Because symbol table is accessible for all the phases of the compiler. All phases of the compiler, all stages, fine. That is the reason we lost it. Suppose the only is not there. Symbol table is accessed during LA and SA. That's correct. Because of this only word, the statement went to the false. Statement is the false. Okay, next one. Compiler, first is wrong, right? Compilers for programming languages that support recursion, necessarily need heap for memory allocation during runtime. Is that correct? Who needed for the recursion? For the recursion, we need a stack allocation, right? We need a stack storage, not the heap storage. That's why this statement also false. Correct? So that meaning is important. Errors violating the condition, any variable must be declared before its use. So this is the violation here. Any variable must be declared before its use. Are detected during which analysis? Is this syntax analysis? No. Which analysis? Who will be verifying that before using that variable should be declared? Which analysis? Semantic analysis. This is not correct. Actually, it should be semantic analysis. That is the reason this statement is also false. Now, is there anybody true here? None of 1, 2 and 3 is correct. Okay, D is the right answer. Absolutely right. चलो आगे चलते. Question number 4. Yeah, this was the one where even I did not analyze when I see the question, because the first time I saw something which is different from the programming languages. Okay, consider the following ANSYS C program, and you have a program. Which one of the following phases in a 7-phase C compiler will throw an error? Will it be lexical error? Will it be syntax error? Will it be semantic error? So you need to go in order to understand the problem, right? So now once you have the semantic analyzer, so anyhow, let's see what is that error. Anybody? Some people are saying A, some people are saying C, some people are okay. Most of you are saying A. Then I'll come to analysis. Okay. Any other answers that you have? Okay, let's think about it. Is this statement, I'm going to show this program lexically, syntactically valid. Look at this program. The same program, right? Everybody knows lexically valid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In fact, you have 12 tokens and no lexical error. Got it? No lexical error, because we know 12 tokens are there, and every group of the characters is a meaningful and valid token. Total 12 tokens we have. And I'm going to show that this program definitely valid. Why? Because you see that the problem is you might have the issue only with this, yes or no? But is this syntactically valid or not? Integer x, if this is not valid, no program contains in the world. But I'm showing it, if you have some statement like type def, right? You have int, int, I have integer. So guys, you tell me this type def statement is going to allow, this is syntactically correct, yes or no? Syntax correct. There is no issue with this. That means there is no problem with this. Compiler assumes this syntax is correct. But what is the problem? This integer has no connection with any predefined. Anyhow, when you look at semantic, oh, this must be somebody, some type, but it's going to look at that, oh, this integer has no connection with anybody, so there is an issue. Then semantic analysis will produce an error. Everybody? Semantic analysis will produce an error. Optimizer, yeah, will not throw this, a very small code, right? Everyone? See this problem. If whenever I write these two lines, oh, there is no syntax error, even there is no semantic error, right? Now when I delete this, compiler will assume, okay, might be integer is having some type def or not, I don't know, because I can't connect this statement with the previous statements. The syntax of this statement is correct, but semantic, when I check, oh, in the semantic analysis, trying to understand what is this X type. Oh, X has no type. Oh, what is the meaning of this? So that semantic analysis will produce an error. X and integer has no types at all. The semantic error also, what error happens? That is clearly integer. There is a symbol table, and X in the symbol table there is entry for both of them, because both looks like identifier in this program, but this here it's not identifier. It will later on, it will replace with the type. So when it looks in the symbol table, this is the ID and this is also ID, and there is no type here. Type column is missing, right? Type, when I look at blank, that means integer and X are not declared. That is going to be an error for the semantic analysis somehow. Okay, very nice. What should be the syntax analyzer error? Something like this. If you have, any guess what kind of errors might happen? If you miss the semicolon, you have written, let's say, integer X, you forgot to write the semicolon, then that will be syntax error. What is a machine dependent optimizer? That we can't speak here at all. Lexical analyzer, what could be possible error? Right, integer, if you want to write something like 1 2 integer, then this will cause an error, because you cannot start identifier with what? A digit. So this might give you an error. Okay, let's go to the next question. Question 5. Oh, that means lexical analysis questions are very easy for you, right? What is the lexical analysis? Basically, it's going to take, so let's understand what is the lexical analysis. What is the lexical analysis? क्या है lexical analyzer? It takes sequence of characters. Sequence of characters. इसी को कहते हैं हम, we tell this sequence of characters only character stream. Right, you can tell this as source program, source code. Okay, and this lexical analysis will produce sequence of tokens. Sequence of tokens. It's going to produce, that is also called as token stream. हो सकता मंजित, yes. Everyone, what is the lexical analysis? And this will produce, even this will use, no doubt, it will interact with symbol table. Of course, symbol table is connected to all, right? And this will produce the lexical error, if any. But it will report to error handler. Okay, many things are there in the lexical analysis, right? So what are the things you will be having in the lexical analysis? Like, many things. Identifying tokens. किसका जवाब है? Lexical analyzer. Identify tokens or identifying tokens. Next, ignoring Of course, you need to identify ignoring comments and spaces, whose functionality it is, and white spaces only, right? Now, who will separate the tokens? The lexical analyzer and parser together. They are going to work together to separate the tokens. Okay, uses longest prefix rule. What else? Anything that you see, right? Identifying lexical errors, reporting lexical errors, all these things are done by the lexical analyzer. Okay. Okay, that's good. Let's move to the next topic, right? That is the parsing techniques. Are you ready now? So that means you have very less questions in the lexical analyzer. You need less time for focusing on lexical analyzer too. Okay. So the most important topic, this is parsing. Maximum questions in the exam comes from the parsing technique. Okay, first one. What is the answer? Don't answer somewhere you studied, right? Solve it right now and understand and answer it. C. Why C? Namaste Kashi. Why it is C? What is the maximum number of reduced moves that can be taken by bottom-up parser for a grammar with no epsilon and unit productions? आपके लिए ताकुर क्लास आपके लिए है यार, इनको बताना यार ताकुर के लिए हम क्लास ले रहे हैं आज. I'm fine Rohit. How are you Rohit? Okay, now let's do it. Now let's try to understand, right? What is not here? What is the maximum number of reduced moves that can be taken by bottom parser for a grammar with no epsilon and unit productions? So you cannot take the productions like A derives epsilon, you can't take. A derives A, you can't take. And A derives, even unit productions also includes this case. So you cannot include these three kinds of productions. Example already provided. And most of the people may not aware these two are unit production. These two are called as what? Unit productions. This is called as null production. Null production. So you cannot have null productions as well as unit productions in the grammar. Then how many maximum number of reduced moves or steps taken? For let's try with one length impossible, right? W is equal to one length impossible, because you cannot write this production ever. But now length of W is equal to how many steps I may take if I should not use this, right? No, it doesn't matter are you using GNF or CNF, doesn't matter here. Only you should not use this three, but you should give the maximum number of moves, maximum number of substitutions. Okay. Now length of W is equal to, I'll try different ways, just try. S, I want to produce, let's say 2 length, W is equal, let's say AB. Now I'm trying to produce AB. One way I can do this, but this is just taking only one. No, this is, I want more. So now let's try. S derives AB. Now I'll use LMD first, right? LMD. A derives A, because at a time only one substitution. B derives B. But again I can't take this one, right? A, B, I can't, right? A derives A, I can't. This is the wrong method. A derives A, what else? If I do this, this is not allowed here. So now this I can't take. Now tell me guys, W is equal to AB, how many steps you have? Okay, let's look at how many steps you have. Focus, don't answer blindly yaar. Kahan se padh ke aaya yaar? See. Right, it's not a CNF, GNF to talk about that. Anybody? Only one way that you have, only one way that production is, substitution is this one. Only this can help to produce the two length. There is no other way, because you can't use these three productions at all. Everybody got this point? No other way. You take some non-terminal, you have to take two terminals to produce the two length. Only number of moves you will be having one only. Number of moves is one. But this is what the bottom up parser. So the bottom up parser, if you want to know reduced moves, just it is reverse. Just AB you need to reduce with the S. This is called as reduced move. One reduced, right? The AB reduced to S, one. So anyhow, you just do one thing. The number of steps in RMD is equal to number of reduced moves. If you know this concept is enough in reverse of RMD, because bottom up parser is what? Bottom up parser means reverse of RMD. Yes or no? How many of you know this concept? If you want to know the number of the reduced moves in the bottom up parser, just you need to do number of steps in RMD. So number of reduced moves, nothing but, you got it right already, this much enough. Number of reduced moves in bottom up parser, nothing but number of steps in RMD. Yeah, just remember this point. Okay. Now length of W is equal to 3. Any way that you can do. One way, S I substitute with, let's say A, B, and this A is definitely, that is only the substitution possible, right? Let's take A and B. So here A derives A I have taken. Here S derives AB. Oh, this is allowed, right? Two length is allowed. There is no restriction with the two length. Now how many steps, how many substitutions we have taken here? How many substitutions we have taken? Two substitutions. Here, if you look at the reduced moves, 1 and 2. So 2 moves, number of moves indirectly here. Number of moves, number of what? Reduced moves. How many? So any length you can take. W is equal, I am taking A, B, doesn't matter. So number of moves, how many? 2. So I hope you got the answer right. By looking at this option, you should get the answer. By looking at this option, but try more. If you want, try more. So if you want, try more here. I'm deleting this. Let's try one more, last one to understand. Let's take W is equal ABCD. How do you get this ABCD? Maximum you should get. S derives AB, and let's take RMD. That B derives CD. This is the only way you can do. And last one, that A derives AB. So how many steps you have? 3 steps. So 3 moves. Now tell me, here 3 moves, here 2 moves, here 1 move, but depends on the length of the string. When length of W is 2, you got a 1. Length of W is 3, you got a 2. Length of W is 4, you got a 3. So what is the relation? In general, you want to produce n, then what is the answer you have? N minus 1. So why did you answer that 2n minus 1? Did I ask the number of steps for n length string using CNF grammar? Using CNF grammar is 2n minus 1. Okay? Correct. Okay, n minus 1. At least 2 terminals, non-terminal doesn't matter. 2 length productions minimum. The meaning of this one is minimum 2 length productions only allowed. So if you want LHS, RHS, this RHS length should be, the RHS length should be greater than or equal to 2. Here it's saying that unit productions and null productions are not allowed, means RHS length minimum 2. Using this condition, try to produce the maximum number of steps. Oh, don't do that. Here 3 length is there, right? You can also write S derives ABC. Oh, don't do that, because we want a maximum. With one move also I can do, but two moves I can do, but three moves, impossible. Can you try? Can you try using the given rules? Can you try with the three substitutions? Impossible. So if you are able to do this using this condition, if you are able to with the three moves, then 3 will be the answer, but 3 impossible. That's why we conclude two substitutions only possible for the 3 length using this restriction. So this is the restriction given to you. LHS derives RHS. RHS length is at least 2. Oh, somebody want a grammar example. Say, I'm just telling you, S derives A, wrong. S derives epsilon, wrong. And S derives AB, correct. S derives AB, A derives A, wrong. Because this satisfies, but this will fail. And S derives AB, and A derives AB, B derives CD. This is correct. Understand the length of the RHS. The length of the RHS should be at least 2. At least 2. And you can see that this is at least 2, but this is wrong. This is a 2, 2, 2. Even you can write S derives ABC. This is correct. You got the point, right? If you want maximum reduced moves, always try to take the 2 length, because if you go for 3 length, you don't get the maximum moves, right? You will get the minimum moves here. So always try to take the 2 length, 2 length, 2 length, so that you will get the maximum moves. You will get the maximum moves. If you want the minimum moves, then take the one production only, everything. If the question is slightly changed, instead of the maximum, if you want a minimum number of moves, do you know what is the answer? Do you know what is the answer? Minimum number of moves? Just 1. S can derive what you want. With n tokens, right? The whole sequence S can do directly. There's no need to do this. S derives AB, S derives directly AAB, S derives directly ABCD. There is just one move is enough if this is the minimum number of reduced moves. Minimum is 1. Right? How many questions are over? I forgot always question number, yeah, 4. Question number 5. Okay, let's go to the question number 6. Can you answer it? Yeah, thank you, Raja. Please like the session. At least, should see as many as lives are there, right? Come on, guys. Okay. Just answer it. Meanwhile, I'll have a water. Just read the question. You have 2 sets of LR1 items. This is actually 1 set. Is it 1 set? 2 or 3? 2 sets only, right? Yeah. This is a 1 set. This is another set. So first answer is as if C. Okay, let's come to the conclusion. Which of the following statements relate to merging of the 2 sets? You need to merge the 2 sets, the corresponding to LA-LR1 parser. It is about false. It's not about the true, right? You need to find out the false statement here. So many statements could be true, and you need to find out the false statement. Cannot be merged since lookheads are different. Oh, that's not correct, right? Lookheads are different, you can merge. The only what you look at, that x derives c dot x in both of them, x derives dot cx in both of them, x derives dot d. Lookheads may be different. You can combine, and you can combine. What do you get? X derives c dot x, comma. You combine all the lookheads, c or d or dollar. And what else you have? X derives dot cx, c or d or dollar, and x derives dot d, comma, c or d or dollar. Now, what is the meaning of this one? This state is present in LALR1, but these two are given as in LR1. So these two are present in LR1, but when I combine both of them, I will get LALR1. So the first one, cannot be merged, is wrong. This is the false statement. Can be merged. Of course, it should be merged. Okay. 2, can be merged but will result in SR conflict. Do you have any conflict here? That you should observe. There is no reduced item. There is no dot at the end, right? So there is no conflict. But it will not result. Will result is the wrong. So this is also a false statement. Can be merged but will result RR. There is no conflict at all. Can be merged, that's correct, but will result in RR conflict is wrong, because it is also false. There is no RR conflict. Cannot be merged. Oh, it can be merged, right? Since go to on C will lead on to different states. That's not the meaning, false. So what is the right answer? D. Most of you answer D. 1, 2, 3 for all the false statements. Yeah, we need minimum one reduced item to get a conflict. There is no reduced item here, so you will never get a conflict in this state. Okay, it's very easy to answer it. Correct? 4 statement. We cannot be merged. Actually, we can be merged. That's enough. We can be merged. Since the reason is something different, go to on C. If we are reading a C, will lead on 2 different states. Doesn't matter 2 or 300. We don't care. First, can be merged or not. He's saying that cannot be merged and you are giving the reason. When will you look at the reason? If really cannot be merged. But you can merge, right? This statement itself failing here itself. They can be merged. This is the right statement, but this statement if failed because of will result a conflict. And can be merged, this is the right. But it is failed because of will result in RR conflict is wrong. And cannot be merged, this is enough, already gone. It can be merged. And here it, so here cannot be merged wrong. Even though here can be merged is wrong, but will result is wrong. Here can be merged is wrong, as can be merged is right, but will result is wrong. So understand in each statement what is the conflict one. In the 4th option, they are saying cannot be merged due to some reason, but there is no reason, we can merge it. If really cannot be merged, you can look at the reason, right? Doesn't matter how many states you go, we never look at because already they are mergeable. We can merge these 2 states. That's why I've shown that it can be merged. There is no reason not to merge. Okay? Is that clear, Tanuj? Don't overthink because the question is already having the answer in the first, right? 2, 3 you need to look at this. Why it is resulting conflict? The 1 and 4 just the statement is already false because of cannot be merged. Because it's merged. It's don't look at here. Why are you looking at on see what will happen? Don't look at this is not required at all. Gone. Already that statement is enough to make it false. Okay? And never look at unnecessary things. Okay, good. Question 6. You are actually going to this side, that is actually you don't need it. 7. A canonical set of items is given below and it's very clearly mentioned this is a dot and this is a dot and this is a state, let's say. And on input symbol less than, what will you get here? What will you get here? Do you get anything here? If you read less than, see you can read greater than. Can you read less than? You get no item here. Yes or no? Because I don't have any less than symbol here. If I read less than, I get nothing. But if I read greater than, I'll get R. But I'm not asking about greater than symbol. So only is about less than. Now look at this state we are talking about. A shift reduced conflict and RR conflict. Is it really you have this set? Is it having SR conflict? Nothing, right? So this is the false statement. A shift reduced conflict but not RR. There is no conflict here. Forget about shift reduce RR. RR conflict but not SR, no conflict. And there is no item, that means there is no conflict. Neither shift reduced nor RR conflict because there is no item at all in this state. Everybody, because of there is no item, you will never get a conflict. Okay, no doubt. Let's go to the 8th. The grammar S derives AS, A or BS or C is dash. Okay, and many people do different way, but we don't need to do different way. We just do a very simple way to answer it. Anybody? Let's see how will you answer it. No answer it. Good. Shifu, why D? Is it not LL1? So we have a shortcut, right? What shortcut we have? S derives ASA or BS or C. How will you check LL1? How will you check LL1? Are you going to design LL1 table? No, right? How will you check LL1 grammar? Just do intersection of all the two. This two intersection, like A, B, pi. So like first of ASA is A. So formula you have, right? Use this formula. Like A derives alpha 1 or alpha 2. We know there is no epsilon. What is the rule you check? First of alpha 1 intersection first of alpha 2. If it is equal to pi, there is no issue, but if not equal to pi means there is a common terminal, then there is a conflict. Then there is issue with this, then not LL1. So now if you look at this two, A intersection B, which is equal to pi, and if you do this one, it is also pi. If you do this two, it is also pi. That means there is no issue with this one because it is LL1. It is LL1. Common prefix just need to check. Okay. The short form. If you have epsilon here, if you have epsilon, then you will write here follow of A. If all the two pairs, all the two productions, their first combination is giving empty because A and B, B and C, A and C, there is no common terminal. The LL1 is this grammar is LL1. You can build LL1 parser for that. So now, whenever, now that's enough. Don't check LR1. If G is LL1, then it is also LR1. No need to check at all. You know this point, right? If it is LL1, then it is always LR1. So blindly you will go to option C. You don't need to go for LR1 construction here because every LL1 is LR1. So this is the very easy question for you. Pen and paper not required. If you know the shortcut, just you will see A, B, C. Oh, no common prefix for any two productions, then answer is LL1. But if you see here, if here this is A, let's say, then this is not LL1. Maybe LR1, we don't know. We have to check that in that case. Okay. Done. Question number 9. Which data structure in a compiler is used for managing information about variables and their attributes? Who is that? Variables and their attributes. Variables might be any identifier, like variables is clear, but in general variable is identifier and their attributes. But one of the identifier type is variable. Oh, that's very easy, symbol table answer, right? Everybody? Yeah. The semantic stack may be used, to understand the scoping in semantic analysis, but we don't know explicitly. And parse table, you are aware of that parsing table, right? LL1 parsing table, LR parsing table, and abstract syntax is similar to the parse tree. So you are aware of it, I guess. Now question number 10, or linked question. So two questions we have. The question number 10 and 11 we'll see in the next. But just take the data. First take this data. This is the given grammar. Okay. So let me compute it. The questions first we'll read and then we'll come back here, right? So we need to compute, let me write the question number also. Question 10 and 11. So this data will come back. The question 10, we need to compute the first sets, right? First of A, follow of A, follow of B. So first and follow set we will compute. First and follow set will compute. And then question number 11, we'll find out what is E1, E2, E3 in the table. So this both we are going to do in the year itself. So can you compute first and follow for every non-terminal? We'll match later. Oh, compiler can use lot of data structures. Okay, compiler. Okay, you also get to know this point. Remember, compiler, it's about different, right? In compiler, you have lot of data structures. In compiler, you have the symbol table, but that is used for the variable identifier and their attributes information to maintain. Another one, passing table, it can use. In compiler you have all of them. Even you have a stack, semantic stack or any stack. There are so many stacks are there. Okay, you also have the trees like parse tree, syntax tree. There are a lot of trees. So these all are maintained in the compiler. But to understand the variables and their attributes, you need a symbol table. Right, to store the grammar we need a parse table. Like to store the actions like shift and reduced and other things, you need a parse table. And stack, to understand the syntax or semantic, you need a stack. And tree, to represent what the syntax, or to represent three address code or intermediate code, you have the tree, like different trees, syntax tree, parse tree, and so on. Okay, they're all data structures in fact. Come on guys. Can you compute? I asked the question, right? What is the question? What is the first of S? What is the first of A? And what is the first of B? After computing this, then compute the follow of S, follow of A, follow of B. Just for understanding and practicing, just compute it. For the grammar below, a partial LL1 table is designed. You need to fill this table completely. Is also represented along with the grammar. Entries are given as E1, E2, E3. Epsilon is, we know, empty string, also called as null string. Dollar indicates end of the input, and bar indicates the alternative right hand. R, that means when you have more than one production you can use a bar. That's fine, everything is known to us. Now using this, can you compute the first and follow? Oh, somebody started computing, good. Okay, just easy, right? First of S, A, B, epsilon, so easy. A, B, epsilon, no problem with the first of S. And first of A, nothing but first of S, follow B, first of B, nothing but first of S. So just copy paste. There is no issue with the first sets. Everybody got the same answers? Everybody got the same answers, first of S, first of A, and first of B? Because all are same. Yes, good. Yes, Chanchal, you're right. Only follow you take time to compute. Follow of S. Follow of S. How many places S you have? 1, 2, another one, because of star symbol you will be having dollar. So one is a dollar. But another one, the follow of S nothing but follow of A, and follow of S nothing but follow of B. So you need to do the union with follow of A, follow of B. So now your problem is follow of A, follow of B need to be computed first to understand follow of S. So first compute them, then take the union here. So let's say follow of A. What is the follow of A here? What is the follow of A? Small b. What is the follow of A? Small a. So B comma A is going to happen for follow of A. You got that point? Follow of A is B comma A, so you can copy it there. Follow of S you can copy, not an issue, because follow of S depends on follow of A here. Okay, fall of A is done. Anything left in the fall of A? Nothing, right? Only B, only A. And fall of capital B is one here. There is another one. Both are saying same. What? The fall of S. Fall of B, nothing but fall of S. So the fall of B depends on fall of S. Nothing else. Fall of B depends on fall of S. And fall of S already we computed $BA. And more than this, you don't have any symbol to take also. If you look at here, there is no C, D, E, F. So no confusion at all. So fall of S this much, and fall of B, when I do the union, again it is fall of S. So it's just recursive copy paste. So this is the fall of S and first of S and everything. Yeah. So once you compute this, your job is done. Okay. So next question is very easy. We'll do that later, right? You can easily match what's going to be the right answer for this. Can you match it? If you have this data, can you match it? The next question. First of A, first of A never contain epsilon. You can delete the option A completely. And first of A never contain epsilon. You can delete this. And first of A is AB comma dollar. And what was the option you have? First of A, AB comma dollar. First of B, AB comma epsilon. And fall of A comma B, fall of B dollar. Oh, what is the question here? First and follow sets for for the non-terminals, right? A and B. Any option is right? Any option is right? Just cross check from here. First of A, AB epsilon. First of B, AB epsilon. Oh, sorry. Yeah, it's correct only, right? Follow of A will not contain epsilon. That's fine. Just cross check here. You know, very difficult when the slide is there. So first of A and first of B is same. This is the correct. And follow of A is AB, follow of B is AB dollar. I'm very sorry. Yeah, confusing for me. So these are correct. A is the right answer. Okay, this is also correct, but the problem is follow of B. This is the wrong statement. Okay, here what is the wrong statement? And first of A, you have a dollar, that's why this is wrong. And first of B is correct. Follow of A is A comma B, follow of B is the wrong. And first of A itself is wrong, and follow of A is correct, and follow of B is wrong. So you know how many are there. First and follow of S contain a similar symbol, so grammar is not, let's see that. Okay, anyhow, that you can match, right? Yeah, I'm just giving you homework. Just match the options according to this data. Okay, that is not a big difficult for you. Now you compute E1 and E2. So in the exam, how do you compute this? Already we have first and follow set, right? Just look at them and look at the grammar and just substitute. See S comma A. So look at that S row. S comma A. That means somebody is there. S comma A. So what is S comma A? S has total how many productions? 3 productions. So this production you are going to add here. So here you are going to add E1 is nothing but S derives A, B, B. So this is the one possibility. Future we don't know how many comes here. We will need to look at. So because of epsilon, S comma A also there is one more. S comma A there is one more. S comma A we are going to add this one. So here you will get S derives epsilon also. Because of this, because of what? S comma A in follow set you have this null production. Because of the first of S comma A you have this production. Now that E1 will have these 2 productions. What about E2? Now E2, when you look at the E2 is also S row. So look for S comma B, S comma B. So out of these 3 productions, this one will be the S comma B, where this production will give you B as the first symbol, right? You know how to look at, I guess. If not, please let me know. And because of epsilon, you need to look at, is there an S comma B? Yes, we have S comma B. So because of this, S derives epsilon also comes here. Now finally E3. How do you compute E3? E3, you need to look at the B row, means B combination. So that E3 is presented dollar. So look at that. B, you don't have any B comma dollar. So because of epsilon, you go to there B comma dollar. So here E3 you will get B derives epsilon. So please note down this and find out the correct match. Definitely this is not LL1, no doubt. Right, this is not LL1, no doubt. Because we will have multiple productions. So this table will not be LL1 table anymore. because grammar is not LL1 table. Grammar is not LL1. Okay, so you can remember this, right? So let's go to the question number. This one is done. 11. Please match it. I'm not good at matching. Just match it. Who is the right answer? E1, E2, E3. Remember that? Epsilon here, E1, E2, and what about E3? E3 is what? B derives epsilon, but B derives epsilon is not there. So one blunder mistake I did. There is no B derives epsilon. What you do? You have only one production, B derives S. So remember this one, you need to take null production, but null production is not there. So indirect null production is there. B derives S, S derives epsilon. So this is very important. E3, null production should be there, but there is no null production. You need to find out this is only the null production, but indirectly. So here B derives S is very important. Okay, B derives S is very important. So who is matching? And also, many things I can delete. See, the E3 B production, E3 S production. E3 never be S production, because E3 is there in the B row, B production only should be there. Okay, so remaining three options. Now E1 and E2 both should be actually S production, but you have given A production, B production, is completely wrong. So this also I deleted just by having the knowledge what should be there in that row. S productions only should be there in the E1, E2. So these two are deleted without having the knowledge of the computation of first and follow set. But this two, now look at E1, E2, you have O. So this is the A production, B production. So here also we have deleted without, that means these options can be answered without computing first and follow, without filling the table. All the three are eliminated. Only very simple knowledge. See here, the simple knowledge is important. S row, you will have S productions only. A row, you will be having A productions only. B row, you will be having B productions. But what is happening? E1, E2 are there in the S row, and E3 is there in the B row. Now in the options shortcut, E1, E2 should have only S productions, right? But here you have A, you have B, wrong. Here the E3 should be the B, E3 should be the B row, right? It's a B row, so that's why we don't. And E1 and E2, you should have S productions only, we delete. And this one is only left, and blindly you can choose if you have not computed. Everybody? Yeah. That's what you need to understand during the practice of the gate questions, right? Blindly you should not answer C by computing what you know, but also you should apply variety of the concepts to get the right answer. In the exam you need to save the time, right? At the end you should answer the correct one and you should save the time. You should know exactly the concept, how I can come to this C quickly. Okay? It all depends, right? But always we don't see such things in the exam, but sometimes happens. Okay. Question number 11 and question number 12. Let's see who is going to answer. Yeah, this one is the question where many times this was answered different way, when including me. See, basically viable prefixes are nothing but prefix of right sentential form, right? That will not allow you to go to the end of the past of the right most non-terminal. So mostly what a stack contains is only a set of viable prefixes. There is also one interesting concept for the bottom of parsers. Do you know this? Set of viable prefixes. If you collect all the viable prefixes, you get just a regular language. There is another concept, the set of viable prefixes, also called as a regular language. So remember this point. In the future exam, they may ask you, the stack contains definitely set of viable prefixes. Stack contains, and this set of viable prefixes is also called as a regular language. So this is actually a regular concept. If you collect all the viable prefixes, right, this is a regular set. This is a future possible gate question, right? Which of the following is right option for set of viable prefixes? Okay. What is right sentential form? The right sentential form is nothing but, if you know, right, suppose you have S derives A, B, let's say A, I'm writing some, something, don't worry about it. A, B derives, okay, let's say a capital B derives C. Now I want to derive some string. What you do basically, right? I want to derive, let's say, A, C, C, A. This is my string. This is my string. So you might be doing some kind of right sentential form. What is right sentential form here? Yes, you will have A, B, A, and what else you have? A you substitute with A, B, B, A, and finally you will have A, C, B, A. Right sentential form I need to do. I'm very sorry. Right sentential form. This B should be substituted first. Then A, C, A. Then A should be substituted. You will get A, B, C, A. And finally you will get A, C, C, A. So this is called as right sentential form. Everybody knows it's RMD. Right sentential form means the sequence of symbols derived from the S using rightmost derivation. So here right sentential forms are this. This is the right sentential form. This is the right sentential form. These are called as right sentential forms. Now the prefix of this one, if it appears on the stack, then it will become right sentential form. Suppose on this stack, let's say on this stack, you have A, see here, you have a C, C, and this AC is actually a prefix also on stack. On stack you have, and also it is the prefix. When you have the dot here, this is the prefix. Then AC is called as viable prefix. That means it should be there in the stack and also it should be prefix. Then we call it as viable prefix. It's called as viable prefix. After some time what happens? This AC become AB. Now this AB is also viable prefix because AB is a prefix. AB is a C is reduced to B, then AB is the prefix of this sentential form and AB is also there on the stack. Now the dot will move further. No, dot not will not move. This AB will reduce to A. And now A is also viable prefix because A is the prefix of the sentential form and also there on the stack. Now the dot will move further, see here, then C comes here. Now you can see that AC is also prefix and also on the stack. That's a viable prefix. Now the C will be converted to AB and so on. These are going to be the viable prefixes. Here, like, you got AC and whatever else you got AB, you got A, C, something like that. AC, because dot is here, right? Then later on sometimes you get AB and finally you get ABA and so on. Okay. Fine. So understand the meaning of the viable prefix. It should be the prefix of, these are the right sentential forms. It should be the prefix of this one and it should be there in the stack, then only we say it is viable prefix. Okay. Every prefix, see here, every prefix will not come. Suppose ABC is there. ABC. Did you see ABCC? ABC is a prefix. Yes or no? Is a prefix, but not appears on the stack. Yes or no? ABC never comes here because somehow B is converted. What happened? That AB is converted to A, but not appears on stack. Then what we say? We don't say it is a viable prefix. Is that clear? So ABC is not viable prefix. Got the point? Every prefix of this right sentential form not viable, right? Those prefixes who appears on the stack are viable prefixes. There is one mistake I used to do. Viable prefixes appear only at the top of the stack. Top of the stack means only the one symbol, right? So you can't consider that statement, okay? Not inside, though that can appear inside, right? That not inside should not be there. That appears at the top of the stack means you can assume all are top, but not inside when you say it, but inside also there, right? So this statement is somewhat confusing because of not inside. They said, oh, inside also present viable prefix, right? A is there inside, B is there on the top. That's what you need to. Okay. Fine. This is called as viable prefix. And viable prefixes are very important for the LR parsers to do the reduced to do the reduction. Basically that reductions is going to happen because of this viable prefixes. Question 13. Okay, let's see. Can you read quickly, guys? Yeah, chart is going very slow, yeah. 2 likes needed for half century. Make it 100, yeah, today. Okay. C is the right answer. ₹10 issue. C. Okay. Good. Lexical analysis. Which one here? That's related to DFA. How it's related to DFA? Because lexical analysis, you need to recognize the tokens. To recognize the tokens, you need a DFA or you need a regular expression. In the exam, they may ask a regular expression. You should use the same. Even they ask regular grammar, that should be the fine. The parsing. So now look at A is matching with the 2. Oh, everybody is saying 2. Then no need to look at. By looking at the options, you can say is a 2. And B, 3, 1, 4. You have the 3 things you need to match properly. Parsing. Where do you use? The parsing is actually using the parse tree. In the parse tree, you have the productions. The productions are going to use the production trees. So parsing is needed at the 4. So now you have this only. So now you got the conclusion that A and B are 2 and 4. Then just check. C is the one. Register allocation is done with the help of graph coloring during the code generation. So this is the very famous one. To do the register allocation, you want to allocate the registers, right? Then you need the graph coloring concept to occupy the less number of registers. And expression evaluation can be done with the help of post-order traversal. Like post-order traversal is one kind of traversal, you know, right? That's used famously for expression evaluation. You are aware of that. The most of the machines, they do post-order or post-fix kind of evaluation. 3 is the D, right? So that option C is the correct. Okay. Let's go for question 14. Not difficult one, I guess. You should know the order, right? So if you look at the power of the parsers, it's about the power of the parsers. Yeah. You know that LR of 0 is less powerful than SLR1 and is less powerful than, okay, SLR1 no need to write, just you can write SLR. That's also same. LR and is less powerful than LR. Or this one, they have used CLR. That's the best word. Okay. Now you just need to do among this SLR, CLR and LR, which of the following pairs identify the method that is very easy to implement. First one, you should use very easy to implement and the method that is the most powerful in that order. First you need to choose easy to implement and then most powerful. So this order you need to write. There could be multiple answers, not 1, 2, 3. Okay, I'll just write the answers now. What are the possible answers? So one way is like SLR, this one, the most powerful, easy to implement is SLR, most powerful among these 3, here it is CLR. But if I give you only 2 options, SLR, LLR, then SLR should be here, LLR should be here. If I give you only LLR and CLR, then LLR should be here, CLR should be here. Okay. Yeah, which one is the right answer? Many people are saying C, right? C is the right answer, right? Yeah, 14. Next 15. What will be the right answer now? Yes, yes, Nishu. Possible. But they will give you everything, right? Somebody answered both S1, S2. You need to choose the correct statements. LL1 can pass all the strings that are generated using the grammar G. LR1 can pass all the strings that are generated using the grammars, right? And now, do you have LL1, LR1 for this grammar? If you have observed this, is it ambiguous grammar? Very simple grammar they have given you, right? It is ambiguous grammar because this F and this H both can derive a C. Yes or no? That means C can be generated two ways. That means this grammar, it is not LL1. It is not even LR1 because the grammar is ambiguous. That means LL1, LR1 cannot pass because you can't implement these passes as they are not LL1 and LR1 grammars. So here the answer is neither S1 nor S2. And also they are clearly mentioned all strings. In that all strings, that ambiguous string also comes, C also comes here. That C is going to make a confusion here, which what action should be taken when C comes. It's going to be confused for LL1 and LR1. Clear? Some conflict will be there. Don't worry what conflict is not required. You will get a conflict, no doubt. RR definitely will get it, but not required at all. You can understand by using the theoretical knowledge. Good. Total 15. Yeah, guys, easy question. See, the compiler questions are pretty easy than any other subject. I feel it. If you know the concepts and very limited syllabus and easy to answer. Only one or two concepts might take time. C. You need to fall off Q, right? Fall off Q means the Q is here. Fall off Q, follow off Q. What do you get? Can I believe it is a first of R? So R you can get a W, but because of the epsilon, when you put epsilon, then epsilon will depend on S. So now Q might depend on R, might depend on S. So what S gives you? Y. So W comma Y, that's it. Yeah, most of you answered correctly, that's good. W comma Y. So what you do for practicing, only they have given fall off Q, just try how to compute fall off P, fall off R, fall off S, like that's kind of practice. Okay, you just do on your own. Suppose fall off P is asked, so what do you answer? P is not there RHS side, so it's just dollar. And fall off Q already done. Follow off R if they ask. After R, that's S, R is appeared only once, right? So it's going to be Y, what S is giving. And fall off S, if they ask fall off S, S depends on P. So what is P? P is just dollar. Okay. So I hope you can compute these things because a very easy grammar. Yeah, question number 17. Which of the following grammar is not left recursive, but it is equivalent to G? Okay, also remember it should be equivalent to G. Okay, two things you need to do. The grammar is not left recursive, and also that must be equivalent to this, because this grammar is left recursive and somebody writing grammar which is non left recursive. Okay, I'll just highlight some of them, just delete blindly. You see, so only you need to cross check which one is the right one. You need to cross check which one is the right one. So by looking at the grammar, you can easily understand which one is the right answer, right? Which one is the right answer? Here only ext are there. Here f productions are there. Here f is not there at all, right? So just understand e derives, that is this is the left recursion, right? So to eliminate this, beta e dash should be there. E dash is here x. So somebody want to convert this, right? How do you do that? E derives t e dash, and what e dash does, that minus t e dash or epsilon. But what did they do? That e dash they replaced with epsilon. This is same as what? E derives tx and x derives minus tx or epsilon. So the first production, the first list will give you this 2, and similarly t will give you this 2, and f is not having any recursion, so will keep the same. So this is the right answer. Everyone, you don't need to do much things, just understand what's happening here, that's it. Here they are having left recursion, so they never be equivalent to this one, and here this two looks similar, but this one is not having all the productions what this one is having. E, T, F, here E is there and T is there, but F is missing, and that's why we are not assuming equivalent at all. But also check that D is it same as this one, because sometimes people might substitute, you might get right. See, where do you have a problem? X is deriving a plus, but will X derive a plus? That you need to check. Okay. Yeah, matches elimination is going to be very easy technique. Elimination is going to be very easy technique, and later on when you left with the two options, just cross check what this is generating, what this is generating, and is it left recursive or not. That's it. But use this technique, you know how to do this elimination, right? You know how to eliminate, right? Just do this approach. E, I did it. Similarly T also, you do the same approach, you will get this two productions. T derives f and t dash, instead of t dash they have y, so t dash derives plus f t dash or epsilon. So just in place of t dash they kept it as y. Yeah, you have a grammar, and then they have some index, just follow them. A is a 3, B is a 2, they have mapping, it just called as a mapping. And whenever you get these symbols, you need to map accordingly the given data. Okay, this one we'll do later. Compute the follow set for the B and write the index values for the symbols in the follow set in the descending order. So there are two orders, ascending and descending, and you might have confusion, so they have mentioned it clearly. The descending order nothing but from highest number to lowest number, 3 to 1 0. So accordingly you need to arrange that terminals. So first compute the fall of B, then we will do the job. What is fall of B? Can you do it? The fall of B nothing but the first of D. What is the first of D? D gives a small d, but first of D not always. The B can also depend on A because of this epsilon. So D might give you epsilon, the B depends on A, then you need to compute fall of A. Then fall of A is only here, so fall of A is a small a. So D comma A. That's all. You have anything else to get? No, right? So you have D comma A. First arrange according to the data. So D is the 1, A is the 3. So now you need to arrange them as like A, D. So what is A? A is the 3, D is the 1. So 31 is an answer. Is equal to, this is the 31. Numerical type, then it is 31. So everybody got the answer? Correct. 31. You need to arrange descending order. Okay. Question number 19. Which of the following kinds of derivation is used by LR parser? See whether it is LR parser or what else? What else? SR parser, bottom up parser, or SLR1, CLR, LALR, LR0 or LRK, anything is given in the exam, they all follow rightmost derivation in reverse. Okay, is there anybody leftmost in reverse? No one. Leftmost derivation, the top down. Rightmost derivation followed by any parser? No one. So these two are very famous parsers for us, but anyhow, personally, practically, there might be a parsers, but might be used for the specific parsers for rightmost and leftmost in reverse. Somebody want to implement that way, then they can do it. Okay, but we follow from left to right scan. We'll scan left to right, so we need only these two kinds of approaches. But if you are following right to left, then you may need these two approaches. We don't know exactly, right? Yeah. 20. We'll take a break, small break after this. Yeah, recursive descent parser is just only theoretical sentence, right? LL1 is also recursive descent, but also it is non-recursive. There are two types of LL1 parsers, okay? But they ask theoretically. You don't need to write the procedures for every production, but you should know what is recursive descent parser. Recursive descent parser means for every production you will write a procedure rather than implementing a table for it, okay? Every production you will be storing in the table if it is non-recursive descent. If it is a recursive descent, you will write a procedure for every production. Okay, it's given that the closure for this computation. So it's just LR of 0 items, right? It should be very easy for you. You need to compute the S dash derives dot S closures. Now start from here. Because of S, you will write S items, that is S dot and dot ID, and that's it. You have L, you will not, oh, S productions are there, oh, not there, L is there, no, that's it. Anything else? That's it. Everybody got the same answer? 5. How did you get 5 yaar? I'm not getting it. Any mistake I'm doing? What's happening? Closure of S dash. Go to right. I'm very sorry, yaar. So I naught is given. I did not read the question at all. I'm trying to do something else. I'm trying to compute the number of items in I naught. That's not given. I naught is given to you, and you need to find number of items in the go to. Oh, the go to is something like this. This is a go to function from I naught when you read a less than. So this is given to you. So now let's look at when you read less than, what happens? S derives less than dot L. That's it, right? And because of the L, you will write all the L productions, L comma S or S. But L is already covered, that's why we don't write again. But S is here, so dot S is here. So we are going to write all the S items again. Okay. And now dot terminal, so we don't write anymore. So 1, 2, 3, 4, 5. Total 5 items are there here. Here how many items are there? 5 items. Good. Yeah, similar question, but that time it was something different, right? This less than symbol was not there. So you are so lucky you got a 0 answer, but now you have 5. Yeah. Can we take a small break and come back? As we know, we have very few questions only. Can we take a small break? What time you want to meet back? Okay, have dinner and come back. Then after that, we will have less number of breaks. Yeah, please go to the mess. I know most of you are, might be staying in hostels or at home, please do it. Have a lunch and come back. Yeah. Okay, see you at 9:30. Think audio video is clear, right? We can proceed the class. So question number 21. Consider the following grammar. We have the grammar number of reduction steps taken by the bottom of parser. Same number of reduction steps, nothing but what you do. Number of reduced moves, reduction steps, all are same. Reduction steps, nothing but number of steps in RMD. You can do that always, but this count only same, but both are not same, remember that. Okay, so now you have this string triple A D triple B, so you need to generate that using rightmost derivation. Okay, S, you have ASB, that is only way you can do that, ASB. So A is generated now. Now we need to go for this B to substitute. That B is has to focus on this B, small b. Yes, small b is already there, so you can go for the small b. So this is also done. Now S is only non-terminal you have, that you should do again. So now A is there, B is there, that S has to be done again, ASB. Now the capital B should focus on this B, and that we will do, let's say double A S double B. And now we have this S. This S need to focus on, how many A's are done? This A is done, right? Need to focus on ADB. So you need to substitute ASB again, ASB. Now see, this B will substitute with the small b, and A already came, so now we'll get triple A S small b small b small b. S you can substitute with the D directly, so final step will be triple A D and triple B. How many steps you have? Just you need to find out how many substitutions, right? One substitution, second substitution, third substitution, fourth substitution, fifth, sixth and seventh. So total 7 substitutions, so will nothing but 7 steps. So answer will be 7. You're good. Okay, no issues. Okay, 22. Can you do it? Answer. Most of the questions are straightforward in this compiler, so only you should practice well with this PYQs. Now 1 2 3 4, it's a LL1 only, right? You need to fill that partially filled table, so you need to find out what happens on S comma C, what happens on S comma 4, what happens on T comma C, what happens on T comma 4. Okay, so just you need to find out. So S comma C, what happens? So only the 4 things you need to compute, like the table, the M is the table, assume that. S comma C you need to find, and M of S comma F you need to find, and other entry is T comma C you need to find. The 4th entry is M of T comma dollar. Okay, this is the 1 and 2 3 4. So to find this S row, you need to compute first of S. First of S, what is the first of S? What is the first of S? You have a D and R. R provides C. and because of epsilon you also get f. So first of S will be D comma C comma F. You have a C, so definitely the production, which one is giving a C? So RF gives. So here you will have S derives RF, because R can provide the C from here. Okay, that's one possibility. Now there is no epsilon, so you don't get any other, but S comma F, you have F also, right? So S comma F, which one will give you F? The only this production, when R is epsilon, you will get that. So F also same. Now look at the option. Is there any way to eliminate? That is also very important, right? S derives RF, S derives, sorry, this is also RF. I'm very sorry. What's happening? Both are same, because the same production will derive C and F as the first symbol. So now in this options, the only option D is giving both are same. Now blindly you can assume T derives epsilon for 3 and 4. If you want, you can cross check that, because of first of T, A comma B comes, but you need to find for C comma dollar. So for of T, when you compute, you will be having C somehow, will having D dollar somehow, so you will go to the option D. So no need to find out that other two, because the 1 and 2 are already giving the answer, right? The only these two are possibilities. Remaining 3 are eliminated because they don't match. Yeah, 1 and 2 are enough. You need to save the time in the exam, right? When you want to save that in the save the time in the exam, no need to solve the question completely. Okay, sometimes solving the question of that's the 1 and 2 can give the answer because of the options. Okay, so that you can do your homework, right? Both will give you T derives epsilon as per the options. Question number 23. Okay, the theoretical questions are straight, right? Most of the questions are theoretical in compiler. Yeah, thank you, Raja. Yeah, can you go to the statement 1 and statement 2? You have two statements and you need to identify the correct option, right? You have two statements, you need to identify the correct option. So now these two statements are correct or not, that's we will see. Every SLR1 grammar is unambiguous, but there are certain unambiguous grammars which are not SLR1. Is this statement correct? If you look at the relation, right, SLR1 context free grammars, LR0 context free grammars, you know this relation, right? LR1 grammars and LR1 grammars, and if you look at unambiguous CFGs, if you look at the statement is every SLR1, if the grammar is anywhere here, every SLR1, is it called unambiguous? Because they're all inside unambiguous, right? Unambiguous class. So these grammars definitely unambiguous. But unambiguous grammar, is it always SLR1? So this grammar, is it SLR1? No. Is this grammar SLR1? No. But these all are unambiguous grammars only. Okay. So now look at the statement. Every SLR1 is unambiguous, but there are certain unambiguous grammars which are not SLR1. So this is the correct statement. Yes. Now S2, for any context free grammar, there is a parser that takes at most order of n cube time to parse a string of length n. So the parsers basically you can go for CYK parser. If any parser using CYK algorithm, right, the CYK parser is going to take order of n cube, because this is basically bottom up parser. This bottom up parser follows dynamic programming concept, and which is in fact takes maximum n cube time. So this is true. This is also true. This is also true. So both S1 and S2 are true. Yeah, good. Question number 24. Oh. It's similar to the previous one. Can you do it very quickly? Can you do it quickly, guys? Question number 24. You have the augmented grammar, so no need to add that extra production, right? So you have the certain terminals, and then you need to find out I naught first. The number of items in the set are it's similar to the previous one, I guess, right? Go to I naught comma what? Oh, there are many things. First you need to find the go to, then you need to find the go to. So this is a very recursive. Previously we have seen only this statement. Now they asked another statement, so you need to be careful. Let's see. First find I naught, that S dash derives dot S. Write all the productions which are going to come here. S derives dot S ash CS, and S derives dot SS, and S derives dot S at the rate. All are S productions only, right? Oh, you know, instead of writing this also, let me give you another short form. S derives dot S, right? So when you want to write S, all the productions you can keep in one line, like dot S ash CS bar, and then dot SS. This can save you time rather than writing every time, you know, left LHS. At the rate dot S dot A dot B dot C. So we have, this is I naught. Just count items 1 2 3 4 5 6 7. 1 2 3 4 5 6 7, right? So this is I naught. Now what you have to compute? First you compute the go to. Once you got this, then again you compute this one. So there are two computations here. First you compute this, then this. So first I naught, from I naught just compute less than. If you read less than from here, only this one is going to come, right? This is only the symbol it's going to be, right? There is nowhere. So now read that. S derives less than dot S, this one comes. Now S derives, all these items again comes because you need to keep them, right? So these 7 items are going to come again. So if you want to remember, you can write just 7 items comes, but don't write all these items in the exam, because this is going to waste your time unnecessarily. You know the same thing comes, just assume it is same, 7 items, okay? So these things comes after computing from this go to. Now you need to compute this go to. Now this one, whatever you get, again less than, again less than. So what happens? If you compute again less than, what you see, you will see the same one, you will get the same one here. You can put a self loop here, right? You will get again exactly same. So now what is the question? Number of items present in this set, how many are there? How many are there? Here 7 plus 1, 8. You got the 8 answer? Yeah, everybody is right. So 8 items you have, because here you will have 8 items. Good. Correct? 24, 25. Which of the following statement is true? Can you identify quickly so that I will cross check what you are going to answer it? Do it, guys. So Chanchal says D, Tanu says A. Is it MSQ? Really difficult point for right now, but answer everything. Try whatever you have it. Understand and try to answer every possible option, whatever it is true. So which one of the following? One means only one, right? So you can also understand is the MCQ type. Okay, one they said it is mostly it's a unique question. Okay. Many answering C, D, C, or D. Come on, let's go to the statement. LA LR1 parser. Understand, you might, if you search this on the Google, right, you will get the answer. That's not the point. First answer, understand every option. The LA LR1 parser for a grammar G cannot have RR conflict. if LR1 is not having RR conflict. You know, right? This is the opposite statement, what actually true statement. LR1 is, when it is not having RR conflict, LELR1 may have RR conflict, but this is a contradicting the statement, right? LELR1 actually may have a RR conflict even though LR1 is not having RR conflict. So this is a false statement. This is false statement. The actual statement is what? LELR1 may have RR conflict. May. This cannot, actually should be may. May have RR conflict even though RR is not having RR conflict, right? But what you will never have, SR conflict you will never have. Cannot have SR conflict. That is the true statement, right? And there are two statements are possible. Either it should be may. If this is cannot, then other one should be SR, not RR. Okay. Now B, symbol table is accessed. Yeah, second time the same gate question, right? Symbol table is accessed during the lexical analysis, but it's not only, right? Other phases also can access. So this is also false statement. C, data flow analysis necessary for runtime memory management. No, right? Inside the compiler also we are using data flow analysis to do the code optimization or do the register allocation. Many purposes we are using data flow analysis within the compiler. So no need to go for runtime environment. Okay. The problem here is you are going for runtime but need not be. LR1 parsing is sufficient for DCFLs. Do you know the LR1 languages are also called as DCFLs. If you want to write a DCFL, you can write LR1 grammar because that language is also called as LR1 language. So all the DCFLs you can represent through the LR1s. So remember that this is the correct statement. Right. Good. Got the point? (36). C once again. What is C? C is the data flow analysis. Is it for runtime memory management? Data flow analysis also used in compiler. The runtime is after the compiler, right? Used also in compiler. Used in compiler to perform code optimization. But this statement is talking about after compiler, that during runtime memory management. Runtime memory management comes during execution, right? This is after compilation. This is a code optimization, or in code generation also this can be used. That's what I'm saying, right? It's talking about after compiler, but this data flow analysis is used in during compilation. Yes. Is a necessary, that means it's talking about it's used only after compilation. That's wrong, right? Used in compiler also. Before runtime also we can use that. During runtime God knows, but before runtime also we can use it. We know that proof. Runtime allocation is done. Runtime allocation could be stack or heap. Anything could happen, right, at runtime. But dynamic memory allocation is heap. In the runtime there are many allocations happens. During execution, what memory you allocate, that is the point. Okay. Again the similar question, right? Now this means this kind of questions are very popular now, right? So many times asked in recent years. I0 is a set of two LR. This is I0 they mentioned. Don't worry about I0. We are not computing in general I0. They mentioned something else. So take these two are I0 and find from this I0 plus. Okay, this is whatever they have given. Assume it is I0. What is it? S dash derives S dot. Don't know what is it, but take it is. Take as it is. S derives S dot plus R. So they mentioned this is I0. It's a given. You are not going to do anything about I0. Okay, it's given to you. Now what you have to compute from this I0, right? From this I0, just you need to compute plus. What is it? Of course, closures when you apply, you will get the same. There's nothing else, right? Now, from plus, if you do s derive plus, sorry, s plus dot r. Now, because of r, you will include all the r items from there. That is dot r star p or dot p. And because of this p, you will write all the p items here. And this s will not come because there is a terminal here. So after dot terminal is there, so we don't consider s again. So these are the items you have. Total how many items you have? 1, 2, 3, 4, 5. You got the 5 items? Yes. Equal to 5. Nice. With this, most of the recent parsing questions are over, right? So by this time you should understand what kind of questions were asked, in parsing, right? One is LL1 table, find the first and follow computation and fill the entries of the table. There's one type. Second, the given grammar is LL1 or LR1, or in future they may ask SLR1, LLR1, and relation between LR1 and LLR1. So if in CLR1, if you merge the states, what happens in LLR1 parser? So these points were asked so far, right? Yeah, so far it was easy in recent years, but if you go for old questions, right, it's more challenging too. Let's go to SDD. Some questions comes are also here. We'll see that. Question number 27. Which one of the following choices is correct? You have the choice also? Oh my god. Okay. Can you read the data first? Consider the following grammar that admits a series of declarations followed by expressions. Okay, something is given, and associated syntax directed translation actions given as a pseudocode. So this represents what? The declarations and expressions, D star, A star. So D represent some declaration like int x or bool x, or the expressions are nothing but something plus something, even plus e2 or not even, or some id. So these are expressions. These three are what? Expressions. When int id is there, you need to record that id.lexim is of type int. So you are going to keep this as id.lex is equal to int. The bool id means that id dot type or lexim is nothing but bool now. E1 plus e2 is given. Check that e1 dot type, e2 dot type are same or not, and that should be integer. If it is integer, then that's going to be no semantic error. Then set e dot type is equal int. When these two are equal as an int, then you will assign this as an int. The next one, not even. Check that e1 dot type is bool. If that e1 is bool, then set e dot type is also bool. And last one, that set e dot type is int, id is int. So anyhow, this is given to you. Only what you need to do. The actions can be used to do the type check, syntactically correct integer variable declarations and integer expressions. So understand the meaning of the given SDT. The actions can be used to do the type check, syntactically correct Boolean variable declarations and Boolean expressions. The actions will lead to infinite loop. The actions can be used to correctly type check any syntactically correct program. So out of this 4, which one is the right answer? Let's see who will come to the explanation. Come on, no answer yet. So look at this two. What is the difference? Both are going to use used for type checking and integer variable declaration, integer expressions. Another one, Boolean variable declaration and Boolean expressions. That D1 is for syntactically correct programs. So which one you will choose here? Is it MSQ type? Which one? Let's see who will answer it. In the exam, they have given one option, but actually it's a multiple options could be correct. So let's look at the first one. The first option, we'll just cross check. The actions can be used to type check. That's okay. The last statement. Correct integer variable declarations and integer expressions. So do you have a variable declarations, integer variable declarations? Do you have integer variable declarations? This is the D, right? It's an integer variable declaration. No doubt, right? Is that expression integer? Yes. Expression is what? Integer. Because final conclusion comes as an integer. See, this is also integer, this is also integer. Anyhow, this is a not is there, that is why boolean comes. But overall, whether you take anywhere, that is going to be final answer is integer, either 0 or 1. Finally, okay? E1 plus E2, the types you are going to check, right? If you are only using this two, then it's a sum of two numbers. It's going to happen. Okay, another one. Let's look at one is integer expression, other is integer variable. What is another one? Is it boolean expressions, boolean variable? Can you assume that? See, boolean you can assume integer, but integer can you assume boolean? That is the problem here. So here conclusion is very important. The option B, is it covered by option A somehow? Can I say that? Anyhow, these two are matching here, but the expression overall, when you look at it, even though it is bool, but finally when it is coming to this expression, it's going to convert into integer somehow. But if you are only writing this expression, then that is only bool. But if you are maximum domination, right, the ID is integer, not of integer. So it's another integer, but it's considered as a bool, true or false. Again, when you use here either 0 or 1, that is considered as integer. So overall, this is dominated by integers. Everybody? Bool cannot be integer. Who is that, Shifu? Integer is what? 0 or 1 is considered as integer. Obviously, there are boolean expressions, there are integer expressions. The both looks fine, but here you are talking about all statements. Can I say all are boolean variables? No. Can I say all are boolean expressions? No. But anything that you do finally, can you assume that is the integer? Because you can see if this is given as, e dot type is bool. If you are only taking this, it is a bool, but that bool value is either 0 or 1. But when you go for this E1 plus E2, that's considered as an integer everywhere. Even ID itself is an integer. So maximum, if you want to evaluate not of integer only, you are going to do that, because this E1 is integer value, right? Except this one, that dominated by integer here. Everyone? Do you agree that? Yeah, only for 0 and 1, this statement and this statement is bound. But this statement is having both boolean and integer. That's what this statement says, but you need to choose only one. In that case, which one you will choose? If it is MSQ, obviously you need to combine integer and boolean variable declarations and integer and variable expressions. Yes or no? So that is the actual statement, but finally, the A is the most appropriate option, because people can lead into that. Boolean as 0 and 1 you can consider as an integer, but integer you cannot assume as a boolean. So that's why you can go to appropriately option A. Okay? Yeah. Option A is the most suitable one if it is 1. And if they want to ask clearly, so it represents both boolean and both boolean and integer variable declarations and both boolean and integer expressions, because you need to choose only one, that you can go to option A. Okay, that's a little bit a tricky question here, right? If I assume 0 1, we know it's a boolean, but you can also assume integer. But if it is 10 12, you can't assume boolean. If you are saying boolean, that statement is going to be wrong. But this one I can say integer, not an issue at all. Okay, yeah, you can convert finally to everything into integer. That's fine, it works. What is option D? Actions can be used to correctly type check any syntactically correct program. Any syntactically correct program, that means what kind of syntactically correct program? Right. So it's not any, right? Only there are only few here. You don't have multiplication, you don't have a division, right? Syntactically correct program is different. That has more operators, more expressions. This is only limited productions. They have the limited syntax here. So the only statement, the why option D we don't choose, is the actions can be used to correctly type check any syntactically correct program. That's a very powerful, right? You don't have the whole program representation here. That's why I'm not able to conclude why this is right D. Okay, so understand we can't represent. Okay. Next. Question number 28. Consider the following grammar along with translation rules. So you have everything. Now the question is somewhere here. Before that, let's read once. The symbols are given and id is a token that represents integer. Id dot value represents the corresponding integer value. Okay, so and so, and subscribe non-terminal indicates the instance of non-terminal, not required, not required. So you need to compute the value at what? S dot value. So you need to compute the value at root, and then you need to have this expression. So for this expression, can you draw the tree first? Okay, so now I'm going to draw, but look at ash means multiplication, and the mod means it's division. Here you can see that, right? You're going to use this concept, right? Mod means division, ash means multiplication. That's all you have. Now let's do it. So can you draw a tree for this? I'm not able to see the expression here. Fine. S1 ash t. So I'm doing it. S, I don't have the space. Okay, S ash t. So how much we have derived so far, that you need to understand. So one ash is derived, right? So this should be t, this should be s, because from s again I can derive one more ash. So here s ash t. Now this ash is done, so this should be done, this should be derived, and this should be t. So this s need to be derived id now. So t to r, r to id. Okay, and then t, the t should be on 10 mod 5. 10 mod 5 you have it, t mod r, and t to r, r to id. Okay, and r to id directly. So we did this side, and after the ash you have t, and t, what do you need? 8 mod 2 mod 2. So you repeat that. So t mod r, and r you can put id. So you got the answer for these two, and 8 mod 2 left here. So t mod r. So I hope everybody able to design this. So t to r, r to id. So you are able to construct the parser, right? You are able to construct the parser, right? You got the answer already. So just do it. If you got the answer, just do it. So now the semantic, that actions or translations are there here. So translations we are going to execute whenever needed it. So you don't need to attach, you don't need to attach here. You want, you can attach, but really not required. So people can attach the translations, but not required. You can analyze whenever needed. You can analyze whenever needed. There are translations here we are not taking into consideration right now. So now let's execute. Let's execute. What is id here? That's given 20, right? This is the 20, and 10. Another id is where? Here 10, and then 5. Here it is 5, and 8 mod 2. This 8, and mod 2, and then finally mod 2. Okay, just let's do calculations quickly. Any answers? Okay, 20 you shift, because you need to look at what r derives id. That's 20 will assign to here, and then t to r. T to r is nothing but r will assign to t, and s to t. S to t, where is it? The t will assign to s. That's 20. Okay, that we know. You know how to evaluate this translations, right? So you always use the concept of LM. What is it? What we say? The L attributed evaluation. So you just take the actions from left to right. First do this, 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So evaluate just from left to right. That would be sufficient. Next, this one. This will be 10, and the same 10 will go here. And now you got a 10, this one. 5 you will get here. Now first time you are going to evaluate this t mod r, t mod r. So what is this means? T1 dot value divide with r dot value. What did you get? 10 by 5 you get is a 2. Then ash means multiplication. Ash means multiplication. So now 20 multiplied with 2 is a 40. Now let's do here. 8 you will assign here, and again you will get 8 here, and then 2 you will get here. 8 divided with 2, mod means division here, so we'll get a 4 here, and then 2 you will assign here. 4 mod 2 means 4 divided with 2 is a 2 here, and 40 multiplied with 2 is 80. So that's it. So I'm doing step by step because you need to understand how do you get that 80. Correct. So in the exam they may ask addition, subtraction, multiplication, anything, just follow them, don't worry about this. These are just syntax, but this is the semantic. You get the meaning from these translations. Okay, here modulo might be there, but here division is there. Here modulo might be there, here addition I can write. It's my choices. So follow my semantic. Whatever the syntax, we don't care. The syntax might be mod, but it might be any meaningful operation here. Here I can do addition, subtraction, follow this to perform the real time result. Done? 28. 29. Can you do it? It's only definition, right? You have the productions and they have some attributes, and which one of the following is true? Okay, let's see who will answer it. Attribute definition. Come on, guys. Please be reactive and try to answer the questions quickly so that I can respond to you, because from yesterday I am almost not having much sleep. First one is L attributed. Okay, what about second one? You have two productions, don't worry what they are. They have assigned rule 1 and rule 2, just follow them. One is given as A derives PQ. Now the rules are mentioned here. Okay, you can take the last, not an issue. P dot I is equal to A dot I plus 2, comma, Q dot I is equal to P dot I plus A dot I, comma, and A dot S is equal to P dot S plus Q dot S. Okay, so these are the rules. You have 3 rules for the same A derives PQ. Three translations. That's called as a rule 1. For the rule 1, this is a rule 1. Okay, rule 2 is above A derives XY. For this they have given X dot I is equal to A dot I plus Y dot S, comma, we have only 2 translations, right? Not an issue. Just take them, not required, but I'm just writing again to understand a little bit more. Okay, these are the given data. This is the given data. In the exam, please don't write, just you can analyze there itself. Okay, just for understanding what I'm saying, you're calculating at P. You are calculating at P by depending on its parent. That's enough, right? By depending on its parent. So this one is inherited, right? So this one is inherited. I is inherited. And what about Q? You are computing at Q. You are computing at Q by depending on its left sibling or parent. So left sibling or parent. So these two are talking about that is inherited attribute. So far I is called as inherited attributes, but we don't know about this other rule, but we are talking about rule 1. So in the rule 1 I is inherited. What about S? That A you are computing by depending on its children, P and S. So S is here synthesized. So S is synthesized, that means you are depending on children, you are depending on parent or left sibling. This all comes under which definition? L attributed definition. So this A derives PQ is following definition L attributed. Why not S attributed? Because if it is S attributed, it must only depend on children. You should never depend on the parent like this. See which one it is? This one. If you want to compute Q, if you want to compute P, you are depending on its parent. That should not happen in S attributed. So what about this one? Let's see. Now X you are computing by depending on its parent. So this is also following almost L attributed. Then Y you are computing by depending on left sibling and parent. So this one is also L attributed. So both are L attributed. Both are what? L attributed. So option is B. B is the right answer, because it's not about the attribute, it's about the grammar definition. They are talking about the grammars. This rule is which definition it is following, okay? L attributed definition, S attributed definition. These are the types of grammars, types of definitions, okay? The rule 1 following the L attributed definition, rule 2 also following L attributed definition, okay? Both are not following S. Anyhow, they did not ask about S attributed. Rule 2, is it calling right sibling? Is it really having any right sibling? X, you are depending on, oh, I did not see, I'm very sorry. See, it's a right reflection maybe. I'm very sorry. Yeah, somebody identified, you are correct. So now I need to re-correct, because X, I was only looking at up to here. X you are computing by depending on, I just see here but I didn't see here. X depends on parent and also depends on right sibling. So this is Y is, X is actually depending on right sibling. Oh, that makes sense. Depends on, thank you for identifying, right sibling. Now I'm looking, off of the person only. The other one, don't worry. So this one is not at all L attributed. Good point. Not L attributed. So I need to recorrect the statement that A is, the rule 1 is following L attributed. The rule 2 is not following L attributed. So anybody answered C? Yes, good point, good point. Because even I do some mistakes, right? If I don't look at every rule. So basically if it is L attributed, just look at one thing, the computation depends on parent or left sibling. It is depending on right sibling, that is not L attributed, okay, or children. So these are the only 3 cases you have. So if you look at the previous options, in this parent left sibling children is allowed, but here you have this right sibling, right? X depends on right sibling, that's why we don't consider as it is L attributed. Fine, good. Second part, first part we don't care. It's talking about rule 2, right? So the first part already failed L attributed, then second part we don't care. If Y you are depending on left sibling and parent, even though this is following L attributed, but the first part is not following L attributed, so this old rule is not following L attributed. So it's talking about the rule, right? It's not talking about the production. The options are very clear. It's about the rule 1 and rule 2. So the rule 2 we say it is not L attributed because some of the statements, some of the translations are violating the L attributed definition. Good. Nice. 29. Oh, 30. So this is only the 130. Okay, which kind of SDT it is? It's kind of again declaration, right? You have a type, you have some identifiers. L represents again this recursively identifiers, like you write sometimes int x comma y. So this statement can be derived with the help of this syntax, okay, this kind of statement. like declaration of the variables can be done with this syntax, and for that corresponding translations added to perform the semantic analysis. Okay, so this kind of statements, like what kind of statements? Int x, for semicolon not required, semicolon is not required, float is also there, like y, and otherwise int a comma b comma c comma d, something like that. This kind of statements can be done with this rules. Yeah, can you analyze and find out? Take any small example and understand what should be assigned to whom. Right, something should be assigned to somebody. Just cross check what is assigned to whom. I need more analysis for this question. Yeah, just do it. Read the question. Consider the following grammar and semantic actions supported inherited type declaration. x1 to x6 be the placeholders. So these are they called as placeholders. You need to identify them, but I don't need all of them. x1, x2, x3, x4, that's all. Only 4 placeholders you need to identify. dt, lr, l1 are mentioned as non-terminals there. Okay. Can you understand by taking at least one example? If I say, let's say int x, okay, just I'm taking the small one. So how you do that? Int x, so d should be there, and t, l. What t should do? Integer. And what l should do? id. Now we know if you are going for L attributed definition, right, obviously this should follow L attributed, because some are inherited are there. You can't use just bottom up parsing, but we say S attributed definition, you can't. So you need to do that L attributed. So now there is a rule for here. That rules will help us to understand. There is a rule here, and what else? There is a rule here, and there is a rule here. So what should be the rules to understand them? So here, see this int id, that means this int is the type, and that type should be stored in the symbol table for the x as an x attribute. So in the symbol table here there is a add type is there, right? So here in x you need to store the type as an integer. So id dot entry is the x, and for that you should have that x6 start type should be integer. So how do you get that? How do you get that as an integer? So we are trying to understand now. So this integer somehow should be carried here somehow. This int should come here, and let's see how to do that, because when you look at that translations, what is this translation? The t derives int. Look at t dot type equivalent. If you look at here, t dot type you got as an int. So now this dot type you will get as an int. That means this we will carry forward to up, little bit up. So now t gets as an int. Its type is an int. Now look at this translation. What is this translation and what is this translation? Right, this translation is what? L derives id. What did you get this here? Add type. Add type from whom? That id dot entry x6 dot type. So this L somehow will get. This L somehow will get. So how do you get it? Of course this may not be here, this might be here, but I'm just mentioning what is the rule. D derives TL. What is that rule? X dot x1 dot type is equal to x2 dot type. Who knows here? T knows or L knows? T we know, the T we will assign to L, so that that integer we can add here. So what we do here, there must be something here, this int we can assign here to right side. So got my point? So now what I'm trying to do here, so keep that one point here, this L dot type should be integer. How do you get that? That here, this should be L, and L I am finding with the help of T. The T should be here. T already I know, so the T I can assign to L. So this I can assign to L. So once assign this, that I can get to ID. So if you want to entry ID, this x6 should be L. So this should be L. So somehow you need to identify like that. So how we store the ID type as an integer with the help of this int. This int will store in t dot type. T dot type will assign into L dot type. L dot type will make an entry into the symbol table. So now we need to understand exactly for each statement. Now look at here. So now the x1 dot type, that means we want to compute this, that is L dot type will be assigned, that we are computing with the help of T. So this will be T. So with this, what do you get? X1 is equal to L, and X2 is equal to that is T, right? That we can do it later. Now just understand each one. T dot type is given, this one is given. Even they didn't ask x5, x6, we will do that. Next one, x3, x4. Now who should be x3, who should be x4? Who should be x3, who should be x4? Understand this statement also. These two are IDs actually. These two are what? IDs. So now here only one ID is there. If I want one more ID, here L1 will be there. So L1 is computed based on L, because L already we get from T, that L will be forwarded to L1. So this L will be assigned to L1. So you are computing to L1 by depending on L. So x3 is equal to L1 and x4 is equal to L. So understand, we take this L and will compute L1. Then we take L1 and we will store in the symbol table. So that is how we get it. X5 is actually coming from what? The L derives ID, right? So L1 comma ID is there. The same L1 you can compute to ID. So X5 you can take L or L1, both will be same. So I'm just taking L1, but you can also take L, which will be actually same. Okay, L1 or L, both will give the same, but X6 is going to be L. So I'm just answering all of them, and now look at which one is going to match. X1 is L, X1 is L, so either B or A. X2 is T or L, X2 should be T, so you got the option A. So now let's check. X3, L1, X4, L, X5, X6 still didn't ask. We are just saying that X5 is L1, X6 L. But here X5 could be L or L1, because both will give the same meaning, because L and L1 will have the same type after computing this one. Okay? Yeah. Any doubt so far here? Good. X5 you can keep L1, or X5 I can keep L. Both will give you the same answer. Because this ID computation, right, I can depend on L1 or L, because parent or left sibling will have the same answer. Any of both, left sibling already computed, parent already you have it. You can take any of them, both are same. This is how the declaration of a variable will get the type into the symbol table. In the symbol table, every identifier will get some type, right? Every variable have some attributes. So there you will get the type by using this. This is called as computing the type for every identifier. This is, in the future they may ask, they will give you all this functionality, right? Hold this SDT, tell me what this SDT does. You should tell that clearly. It computes the type for each identifier and stores in the symbol table. So that's the functionality of this SDT. Okay, just one example is needed to understand. If you don't have this example, right, you cannot get this idea how the computation of the types are happening here. Okay. Yeah, question number 31. Yeah, this question is from, I think this is what? Question is from the syntax analysis. So this is a move to semantic. Anyhow, understand this question is from the second chapter, previous chapter. Can do it. This should not take much time. Everything is there in the data itself. My chart is working very slow. In between ads, A. Yeah, now I can see many are saying A. How do you analyze this, right? Expression is given, tree is given, tree already having the answer, you can follow it. This input is not needed at all. Remember that this input is not needed at all. Directly you can look at that tree, you can compute. Okay, you can look at that tree, you can compute. So let's look at dollar has highest precedence and it is left associative. What is having highest precedence? What is left associative? What is right associative? You can just look at here. Now you just compare 2 ash, right? Just compare 2 ash. Let's look at here. You can just look at this portion, because here you have the 2 ash. Which ash will be considered first to evaluate? When you have this ash, right, where it is at, D ash, E ash, F, this one, right? This ash. These 2 ash, when you consider, which ash will be evaluated first to understand another ash? Is this considered first? No. Without evaluating this, this will never have a meaning. So now, left ash, right ash. Left and right. Without evaluating this, you will never have the meaning to another ash. So who is having more precedence, right ash or left ash? The right ash. So this ash is right associative. Ash is what? Right associative. Is that clear, everyone? Means right to left associative. Right ash will have more precedence than the left ash. Okay. What about the dollars? Now you compare these $2. When this is the left dollar, this is the right dollar. And when these $2 are coming, which dollar should be evaluated first to get another dollar meaning? So this dollar, can I evaluate first? No, because this dollar depends on this dollar. So this dollar I can evaluate without depending on that. So the left dollar is evaluated first. So left dollar is having more precedence, means left right. So dollar is left associative. Dollar is left associative. Clear? Now we got the 2 points. Ash is right associative, dollar is left associative. Now when both are present, ash is present, dollar is present. Now focus on this too. When both are present, who should be evaluated first to consider other? So can I do ash first? No, because this dollar has to be evaluated to understand that ash. If you don't understand, if you don't evaluate it, this ash will not get the answer. So dollar should be evaluated first and then ash. So who is having more precedence? Dollar has a more precedence. Dollar has a more precedence. That's all. Hash is having less precedence. Now just you need to choose option A. Dollar has highest precedence and it is left associative, and ash is right associative. All are matching. Okay, remaining options will not match with this. Good. That means this tree has maximum answers that you can pick. But this expression you can't conclude, because this expression has no parentheses, nothing. So that is the best option to do. No need to look at this at all. (31) 32. Very easy question. 32. Try. I hope it should be very easy. Just evaluate SDT from left to right. That's it. Evaluate the SDT from left to right. Yes, without a tree you can, but you need a grammar. So here I need to understand many things. If you want to find the precedence, right? Precedence are associated, right? The precedence rules can be computed with a syntax tree. That's a given, right? Or with context-free grammar, or with the precedence table, or these things can be provided with the English sentence or in theoretical form. In theory also we can mention that theory precedence rules can be mentioned through precedence table or even theoretical sentence. So these are the three famous representations to compute the precedence rules. Context-free grammar also can give you precedence rules. Syntax tree also can give you precedence rules, and precedence table also. Sometimes even expression also can give, but expression should have the well balanced parentheses, right? When I assign a lot of parentheses, for that you can consider the expression tree, and then you can calculate the rules, right? There is no unique form that what will be given to you. Sometimes they will give you tree, sometimes they will give you grammar, sometimes they will give you expression, sometimes they will give you table. All of them you should consider to understand what rules are given to you. Rules might be given in any form, okay? You don't need, you just use L attributed for the next question. Use L attributed, that would be sufficient. Okay, what is the input for you? What is the input? AAB. Can you draw the tree? S derives A, and that capital A should derive S, B, and S should derive A. That's it, right? A, B. So just attach the rules. What are the rules? There is a one rule here. Just you can take the down. There is a one rule here. You can take the down. And there is a one rule. You can take the down. So this should be the first, and this should be the second, and this should be the third. Evaluation order I am talking about. First, second, third. So what will be the output we will write now? What will be the output of this? S derives A, that is print 2. So it's going to print 2. And second, that is A derives SB, that is print 3. This is going to print 3. Third, S derives AA, that's going to print 1. This is going to print 1. So 2, 3, 1 is an output. 2, 3, 1 is an output. Okay. This is what? This is a precedence table is given, right? This is theoretical form. Exactly, it is not the precedence table, but table only, but theoretical table it is. And here also you can get the precedence rules. But it is clearly given, no need to compute, and they wanted to compute the expression. So now for this expression, you should use that rules to compute. Any extra data not given? Not given, so don't worry. Plus is high, minus is a medium, star is low, plus following left, minus following right, star following left. Follow this, don't use a C language expression, right? It's not about the C, it's about some programming in the world somebody implemented. Don't worry about it, okay? Oops, OBS has crashed. No. Very sorry. Is that audio video fine, guys? Yeah, I know I should take the rest. You know, right? How I'm working from the yesterday. Yesterday I went to the duty from morning to evening. I came in all night and I took the class till morning 4, but I did not sleep till 6:30, and I went the office till by 9, and then still I did not sleep, right? So it's very hectic to continue the class, but still I'm doing it because still I'm not feeling much burden on me, okay? The value of expression. Now look at plus is I. So evaluate first plus. What is 5 plus 1? 6. So I got the 2 minus 6 minus 7 star 3. So plus is I. So plus evaluated first. If there are 2 plus, the left plus should be evaluated first. The minus is the medium. So next is the minus. So minus, there are 2 minus. Then minus is following right associative. That means you should do the right minus. You should do the right minus first. Why I'm doing right minus? Because minus is right associative. So there are 2 minus, will follow right to left. So 6 minus 7, then we will do another minus. So 6 minus 7 is what? Minus 1. 2 minus of minus 1 is what? 2 minus that you got minus 1 multiply with 3, and 2 minus of minus 1 is 2 plus 1 is the 3. 3 multiply with 3 is what? 9. You got the answer? 9 is the answer. Yeah, Raja, I'm in Bangalore working at some IT. Okay, that's good. So answer is 9. You are able to understand, right? So this one, by keep on changing, right? If this star is high, what is the answer? Plus is high, what is the answer? Minus is high, what is the answer? If this is left to right, what is the answer? If this is right to left, what is the answer? So every possibility you can practice. This question give you nearly 30 to 40 questions by changing a lot of data, right? Here 3 combinations are there, here 3 combinations are there, right? Almost you have lot of combinations here. Yeah. So you can practice on your own. That you got the idea right already. 34. So this is another data. See, now grammar is given. Now you need to identify the associativity, what? Precedence rules. Yeah, Lalit. Embedded. Yes, Raja. What is the answer? Okay, it's about only associative, right? Nothing else, not the president's highest or lowest. So now only the associativity is the matter. Plus is dash associative, that you need to identify. And another one, star is dash associative. Left or right, that's it. Left means left to right, right means right to left. So now let's look at the plus. Where is the plus here? Only here, right? When the plus is here, there is a right recursion. Can you see? The plus associated with right recursion, yes or no? Associated with right recursion. Do you know what is the meaning of this? When you are doing right recursion, if you look at that, something like this, plus is already there, q plus is there, and this p you are again substituting with q plus p. If you are doing right recursion, the right operator will have more precedence, means that plus is going to be right associative. It's a very simple concept. Like when you have the right recursion, the right operator will have more precedence. When the star is associated with the left recursion, see, t derives t star u, it's following with the left recursion, so the left operator has more precedence, so star is the left associative. Are you clear my point? If that operator associated with the right recursion, it will follow right to left. If that operator is associated with the left recursion, it will follow from left to right. So the star is left associative, plus is right associative. Right, now what's the answer? You got plus is right and star is left. So you already answered B, right? Yeah. With this, we have completed even SDTs, and many questions are there, 34. A lot of questions are there, maybe coming later, I think. Okay. So this question is mixed, right? L attributed should come there, and all mixed questions are there. Can you do it? Question number 35. Yeah, that Raja Babu, we can speak that offline, not here. So there are many questions. Let me see what happened to this question, right? So 49th slide, right? So many questions are there. I don't know how did they mix up the code generation. Yeah, there are many questions left here. You can see there is 83 slides. Now we are at 49 only, 50 only. That means 33 slides, almost 30 questions more. Okay. Anyhow, that you can take homework. I'll just do as many as I have the patience now, because that my application is going to crash. It's showing that it's crashed already. Okay, can you do it? Which of the following statements are true? Can you find out the true statements quickly? Somebody is answering A, somebody is answering B. Which one is right? Majority is going for B. Okay, let's see. There exists a parsing algorithm for some programming languages whose complexities are less than theta of n cube. What is the meaning of this? Parsing algorithms, right? Parsing algorithm means verifying the syntax, nothing but membership only, right? That's a less than theta of n cube. Right? Is it less than? Right? Is this true or not? Less than or equal? That's fine, but it's near to theta of n cube. Is this true or not? Because you have the CYK algorithm to do that. Maximum it takes n cube, but it's less than theta of n cube. True. A programming language which allows recursion can be implemented. It's a previous question only. Previously they said heap, now they are saying static. Both are wrong. We need to support the recursion, we need a stack. So this is going to be the false. Right? One is true, but two is the false. And no L attributed definition can be evaluated in the framework of bottom-up parsing. What is the meaning of this? No L attributed definition can be evaluated in the framework of bottom-up parsing. See, if my grammar is L attributed, can I evaluate using S attributed? I can, because some of L attributed only S attributed, right? If you look at S attributed definitions or S attributed grammars, right? This every S attributed grammar is already L attributed, because if you look at the L attributed grammars, all these are L attributed only. This L attributed I can use the bottom-up parsing, because this satisfies this grammar satisfying both of them. So this grammars I can use bottom-up parsing, but here no L attributed will follow the bottom-up parsing. But wrong. These are L attributed, they can also follow bottom-up, but this L attributed are different. They don't follow bottom-up parsing. So they are talking about no, means every L attributed definition is not following the bottom-up parsing, is wrong statement, right? But if they say some L attributed, that's fine. Some is obviously correct. Code improving transformations can be performed at both source language and intermediate code level. Source means the high level language. So that's editors can do that. If you want to improve the transformations, right, you can also plug into the editors, like you have Eclipse, NetBeans. There are so many editors, right? If you allow them, they also do the code optimization, right? Not only that, in a compiler, this is basically inside the compiler. This is in editors. Editors can when you type the source language, right, before giving to the compiler, they can also do some transformations to give the optimized code to the compiler. So anyhow, that's other job, but still this is possible. So it's a true statement. But if they ask in the compiler what are the optimizations are possible or we are doing, there's one is at intermediate code level, other is assembly level. So two optimizations we are doing inside the compiler. Okay, now 1 and 4 you go for option B. I think in the app it should be provided. It's already provided. No, sorry, it is with me. I will provide them, they will upload it. I'm very sorry. Okay, I'll ask them to do that. Okay, it is with me. I did not share it. Match the following. Yeah, answer is you are giving B. This previous one only, lexical analysis. Same, previously they have given finite automata, now they have given regular expression, same option, right? Top down parsing is following leftmost derivation, and semantic analysis will follow the type checking. Runtime environment, the activation records will be created. Just look at which one is matching. P is 3, okay, only one is there. Yeah, with already one can answer it, you don't need to worry about much. P is 3, Q is 1, that no need to look at this 3. So if you look at the P, right, the answer is already there. 1, 3, 2, 4, 3 only right for the P, so you can do that. Yeah, very simple one. Only P is enough, correct. Good. And question number 37. Okay, match, but read the question, don't match blindly. Match the following according to the input to the compiler phase. So and the input is the left side and then what is that? Another one is the compiler phase. This is the compiler phase. This is the input to that phase. So this is the input, and this is the phase. And for this phase, who will be the input? And in future, they will confuse. They may give the output and they may give the phase. What will be the output of this phase? So understand, in future, this might change the output, then answers will vary. C, everybody answering C. Okay, let's check. Input, syntax tree is an input to whom? A code generator, syntax analyzer, semantic analyzer, right? Syntax tree, oh, input to whom, yaar? So this one I am just leaving it because syntax tree, parse tree, there is a slight confusion, and here I don't know what they are trying to assume. So syntax tree actually intermediate representation. So if they are assuming parse tree, because parse tree also represents syntax basically, then this might change the meaning. So in this question there is a glitch, or there is a confusion. There is intermediate code representation, there is a syntax tree. Actually both are same. Okay, so this syntax tree, they might be assuming the parse tree, but we are not aware. So I am leaving for some time to get a clarity what tree they are assuming, because I am very pretty sure, because this should not be there. Okay, now let's come to the character stream. Character stream should be the input to the lexical analyzer. We know that. So that Q should be 4. Q should be 4, and we have the two options, so A and B left. Now here the P 1 and 3, P syntax tree 1 or 3, is it code generator or is it semantic analyzer? See, there is a confusion. It could happen anything, right? If this is the parse tree, then this could be the input to the semantic analyzer. If this is syntax tree, this can be intermediate code, can be to the input to the code generator. See, they are matching both. P is matching both. Now go to the R. R is 192. What is R? Intermediate code representation. Now exactly we know what is intermediate code representation. Will be an input to the code generator. So now the R should be 1. R should be 1, then we can go blindly to the C. Are you getting my point? When there is a confusion, please do understand there are some statements you cannot avoid, right? They are ambiguous statements basically. Okay, last one you can see S is a 2. What is S? Token stream. Token stream is definitely what? Token stream input to semantic analyzer. Is that 2? What happened here? Did I miss anything? Token stream, right? Is correct, right? Syntax token stream in sequence of tokens will be an input to the syntax analyzer, and its output will be parse tree. Its output will be parse tree. And code generator output will be, output I am talking about, code generator output will be assembly code, and semantic analyzer output will be annotated parse tree. In future, what options you may face? And lexical analyzer output will be token stream. Okay, that inputs mentioned here. Yeah. Good. So only the confusion might happen. The syntax tree, why is an input to the semantic analyzer? So this syntax tree is assumed as actually parse tree here. Okay, that's fine, because parse tree also represents the syntax. So the actual syntax tree definition is different, but here syntax tree represent the parse tree here. Okay. Question number 37, right? Done. Question number 38. Yeah, guys, can you do it from here? Because these questions even I can come in the marathon session, revision session also. Do you want to practice on your own from here onwards? Because I'll share the PDF anyhow from 38 onwards. Will you do that? We'll spend another time, because need a little bit effort to explain these questions. Got it? Okay, some other time, not exactly the special session. We'll do it. So from this 38, I'll just bring into some other session. There we'll practice. Like after the revision of what? the Maha revision we have, right? Whole compiler division, whole compiler design revision. At the end we will take these questions. Yeah, you can try this and you can answer it like 38. So few questions are there, 30 questions left I think. So please do it, and answer at the in the comment section, so that I'll cross check. I'm showing the every question, just answer it. We'll discuss them later on in some other session, but you can take every question into the practice. Okay, I'm just showing that questions, and you can pause the video and you can understand every question. It is also previous model, like from the tree you can understand the precedence rules. Okay, this question's not explained yet, but I'll do that later on in the scoping. Okay, 45. Did they miss the question number? Oh, this is only 44. Same data. Same data it is. 45. Okay, this is a common data for next two questions, right? So this will be the 45. Okay, pass it. Read this data carefully and answer this 45. So most of the questions are straightforward. Some questions really need an effort, like this 45, 46 requires some effort to understand what is memory spill, these things, right? I'll come up with some other session to understand this. These are the code optimization questions which were asked in the previous years, that before 2015. 48. Many theoretical questions are. Now this question is really interesting, and you just try it. I'll definitely convert. Just do in this direction to understand, and focus on what is integer and what is character, and you will get it. Okay, 50. And yeah, how many questions are there here? 51. Just take this question and answer it in case if you are able to do it. If you are not able to do, and let me know the number so that I'll bring to the practice session too. 52. So this all end questions are going to take much time in the explanation at least. You can try quickly, but for me it takes time. 54. And this is also a very interesting question, right? Control flow graph question. And practice the control flow graph, and you may expect this year in case if they want to ask. 56. Minimum number of variables for what? SSA and 3 AC is always important. It's not difficult one, just need to understand the derivation. 57. Okay, 58. Okay, because tomorrow I need to go for work, so maybe I better to stop now. That's what my target is. 60, 61. Any difficulty? Yeah, DAG, the 3 address representation. So please practice this, and don't forget to answer the comment in the comment section for every question. I am numbering it just to practice them. Okay, and if in case if you are not able to understand this, we will come up in another session, right? 63. 64 is what? It's about optimization only again. Yeah, I think that's all. 64, right? So we are almost how many we did? Nearly 40. Nearly 40 we did, and then the remaining 20, 25. That please do it as homework. We'll just take care in other session. Yes, Tanuj. So there, if you have any doubts, right, please you can ask right now. The doubt session, I am assuming, because right now I don't have the patience, at least I can clear your doubts if you have any. Okay, like you are asking the question, right? And now you can spend the time if you have anything to ask with me. Like a revision through question series on English channel is different from all our practice and revision series. Yes, because we are going to come up with some questions that will help you to revise. Like we have the sequence of the concepts, we know, right? So the concept will be explained the question, and then if required we will also explain the concept. Correct. So that is going to be very interesting for you, because it will be revision for you. Here what happens, the question only we are explaining, but the concept related to that question we are explaining. But in the conceptual questions we will try to ensure that the most of the concepts are there in the syllabus will be covered. That's the main target. In case if we miss anything, you can remind there, we will explain too. That's going to be more interesting than practice. Yeah. Chalo. Arkush, yeah, thank you for attending the session, and you know trying to give the best effort, but sometimes every time we not give the same effort, right? Consecutive days will be very difficult, so we'll look into some other day. Yeah, I'm going to do that today. At least I need rest. Yeah, then see you in the next session whenever we plan. Okay. Yeah, thank you all. Good night. Good night. Yeah, I'm going for that. Yeah, nice to see you all, and see you in the next session. Bye bye, take care.